Okay. So last meeting, I introduced you to a new program which is used for if then else programming in the analytical engine. Okay. Because if you write a program in normal programming language, what programming language are you using in the other class? Anyone? Diba? In your programming course, what program language are you using? Diba, you're doing programming currently? Anyone? Ms. Juarez, are you there?
Yes, sir. C++ po.
C++ tayo. C++, everyone? Okay, C++ tayo. C++ compile. Who's the teacher there? Okay. Input. How do you input a variable? How do you input a variable in C++? What we are trying to show here is an if then else statement, which is equivalent to your C out, okay, and C in, okay. C out will do this, and C in will, okay. So let's do that here. Ano bang kailangan uses streams. Ito. Let's copy this. Diba? So this is how you do it in C++. You type a number. So what we'll do is we ask for the score. Then we do a C out again. Shall we call this int s score items base, okay? And grade. Float ba? What's grade? Double ba? Double or float? Let's try this anyway. So ayaw niya ng double. Okay. Ayaw na niya ng ano. What's the equivalent of float? X is not declared in the scope. Why? Wala pa pala ang X. Let's use S. S. No, C out lang tayo dito. Okay. Let's put this return 0 there. And we'll see in are you doing it like this or printf or scanf? Okay, are you doing it printf or scanf? Pwede rin, di ba? Okay, tama na siya. Bakit? Oh, is there TMP? Score is 60. 50 na. 100. Like that. Okay. That's all. And we'll compute ask for the base. Exit ba tayo? Is that correct now? Exit is like halt. Okay. Now, this time we input the base. For converting, we are discussing here how to do it in no? C++, no? So 60, 100. This assignment that you're supposed to do, no? But this time in the analytical engine. Okay, exit works. So how do you compute a grade? What's a float in C++? Float. Okay. Float G as the grade. What's the grade? Is equal to score over items times. Sabang times dito. Times 100 minus B divided by B. Okay. And then C out. Your grade is B. Okay. Are you familiar with this, everyone? Or am I speaking the wrong language? Kasi pwedeng print F and scan F, no? Okay. 60. Shall we say that items is 100 and the base is 40. Your grade is 40. Why is this 40? It should be 76. Anyone? B pa lang nilagay ko G. It should be G. See, we're not paying attention. No? 60. 100. Mali na. Run again. 60. 100. The base is 40. 40. Your grade is 0. Why is it 0? How do we convert this into a float? Let's just make this an int. Int na lang muna para i-round up na niya. 0 pa rin, no? Anyone who's good at C++? Sir, may nasa waiting room. Okay. Salamanca Vales. Larabaster Pontino. Salamanca Vales, Larabaster Pontino. Larabaster has been here, no? I'm sorry. Did I record this? Parang hindi ko na-record, no? Salamanca Vales. Okay. Na-record ko na, no? And we have anyone else? How do we compute a float in C#? C++? Kasi 0 siya. Plus B yata yung last. I'm sorry, yeah, mali. Yeah, pala mali. Thank you for noticing, okay? So, 60. 100. The base of conversion is 40. 40 pa rin yung grade. Bakit? score over items times 100 minus B plus B. Anyone? Anyway, our purpose here is to show that if G is greater than or equal to 75, and then we will see out is you have passed the test. Else, tama ba ito? May semicolon ba? See out. Try again. Next. Okay. Migrinyo ang trangkilan. Abudlong, are you there? So gano'n, no? Yung semicolon here. Anyway, we'll do JavaScript, no? Later. Okay, so ganun siya. Try again next time. I'm not sure why it's a 40, no? What's wrong with my computation? So isayin nga natin ito. Okay. 100. Ganun pa rin, no? I'm not sure why it's like that. We'll change this to a float. Sa float lang, no? Okay, the base of conversion is 40. So there's really something wrong with the computation here. Anyway, this is what we are trying to do, no? In our assignment to be done next meeting. Okay. So although, no? Although the analytical engine is a very crude machine, okay, it's still considered to be, ito yung grade computation, okay, 74.99. When you say it's greater than or equal to 76, divided by 100 ba? S divided by, okay, divided by 100, is that correct? Score over items times 100 minus base. S. I, right? Score over items, right? So anyway, I'll figure this out, no, later, no. Then anyway, in my other class, I was using Python because they were using Python in that class. So anyway, halos pareha lang naman. The point is, we were able to demonstrate branching. Branching is done in the analytical engine using CF. Okay, what we do is we do a subtraction, okay, of the base, rather our cutoff minus the actual score, and then we do a CF. It's negative, which means that it's passing. So we change the previous assumption, which is failing. Okay, which brings us to a new lesson. Any questions so far? Okay. I will try to review my C++. I'm doing C# currently, you know. But I'm not doing using the old streams IO nor the STDIO anymore because it's in Windows. They're not they're rarely used. Okay, so that's about it for the analytical engine. We will study the next important, no? Kasi after that, merong INIAC and EDVAC, di ba? INIAC and EDVAC. But these are not considered very significant inventions, except that INIAC has coined a new term called accumulator. Do you follow? To get rid of the distinction between ingress and egress. Okay? John von Neumann in 1945 started the invention of a new computer with a radical component. Radical being completely new. Trailblazing ito si John von Neumann. John von Neumann is considered as one of the most important figures in computer evolution. No? He's almost as the same level as Alan Turing and Charles Babbage. He's an American. No? Do you follow? Because what's the invention of John von Neumann? Anyone? It's called the stored program concept, no? Which is built into the IAS machine. Why is it called IAS? Anyone? It's called IAS for short of Institute of Advanced Sciences. It's a department in the Princeton University. So Princeton, ito siya katulad kay same as Alan Turing. Although he was there earlier from 1930 to 1933. And then, but he was working with the IAS already, no? So I think most probably they must have seen each other there because von Neumann was teaching in 1930 to 1933 and Alan Turing finished his PhD in 1938. Okay? And then by then, no, John von Neumann was working already in the IAS of the same university. No? Because this one was completed in 1951. Okay? Almost the same time as EDVAC was also completed. Only a few months earlier, no? Hinabol ni John von Neumann yung release ng EDVAC. And before EDVAC was released, he was able to release the IAS. And the strange thing about that, no, is in 1946, no, before EDVAC was starting, no, John von Neumann released a document on the design of EDVAC. So people were having doubts on who really is the author of EDVAC. Who invented the EDVAC? The inventors of ENIAC. No? Galing sila sa Penn State. Si J. Presper Eckert and John Mockley. So, the IAS machine is a binary computer, no longer decimal like ENIAC, no? With a 40-bit word, 40-bit words. Ibig sabihin, the grouping is not by bytes, di ba? How much is 1 byte? 8 bits. How much is 1 word today? Anyone? Today, how long is 1 word? Kasi byte or integer, di ba? If you're doing C++, you should know how much one word is. It's called a long. A long int. 1 word nowadays is 32-bit. 4 bytes. Okay? So during that time, the IAS is 40 bits. They are not used to using the size in powers of 2 yet. Okay? Nowadays, if you divide that, no, and it has a memory of 1024 words. If you divide that, 1024 times 40 divided by 8, that's 5.1 kilobytes. Okay? In our present terms. Negative numbers were represented in 2's complement form. We will define how that thing is done. Okay? How to compute later, no? When we study in our future sessions, okay? Now, this is the problem. Not all designs are perfect, okay? There's a very good design, but it's not perfect. There's a reason why it's not, okay? It uses 40-bit words for storing numbers. They follow good enough, whether it's fixed point or floating point, no? Okay na. However, it only uses 20-bit words for instructions. Diba? This is a strange invention. If you are new to this is strange. In fact, it's abolished now. Why is it strange? Because you are going to use a program differently from data. Okay? What's the whole point then? Why not use a 40-bit word and a 40-bit instruction set? Bakit hindi lang 40 tsaka 40? Nowadays, when we say 1 byte, 1 byte din, di ba? Hindi pwedeng 1 byte tsaka 2 bytes. In a 32-bit computer, you know Windows 32 and Windows 64, right? Words are 32-bit, which means that instructions are 32 bits. In a 64-bit computer, only the memory is bigger, but the instructions are still 32 bits. Whether data or instructions, the memory stores 32 bits. Dito problema ito eh, kasi 40-bit kung data, 20-bit kung instruction. We'll find out why, no? Why it's a problem. It's difficult to program. Now, why did Jan van Neumann do that? Kasi memory at that time was very expensive. Okay? So, if you are going to use 40-bit words, half of it will be lost if you are going to use 20-bit instructions. Instructions, there are few instructions. You don't need 40-bit instructions, only 20-bit. Okay? So to be able to use the whole 40-bit words, Jan van Neumann designed the execution such that during execution, no, the 40-bit word is divided into two, a left instruction and a right instruction, okay, which made the IAS very difficult to program. We'll try to find out later. No? Here's a comparison between the IAS and the analytical engine. In terms of the number system, the fixed point decimal, the analytical engine uses fixed point decimal. And the floating IAS uses floating point pala, no? It's good that it uses floating point. 40 bits then. Maybe the 40 bits was patterned after the analytical engine. Okay. And it uses, the analytical engine uses 2 input registers and 1 output register. The IAS has a different set of registers. It has 1 accumulator, 1 multiplier quotient, general purpose registers, which means like input and output. No? Memory address register, memory data register. No? We will look at this closely later, no? When we study introduction to computer architecture. Okay. The input output is a Jacquard loom for the analytical engine. Now, the IAS already has a secondary input and output device, maybe a tape already, no? But it can also use IBM punch cards. Okay. So the main difference in concept is this. Okay. Ito yung nakita ni Jan van Neumann sa IAS design, no? Jan van Neumann saw some problem with the IAS, with the analytical engine design. Remember that in the analytical engine, programs are loaded. We fetch sequentially, no? Number cards, operational cards, variable cards, via the Jacquard loom. Okay. One by one. Okay. We fetch one program, execute in the store. Okay. And the data are stored separately in the store. No? Diba? As we have shown in our demo, no? Instructions from the Jacquard's loom are fetched one by one and processed by the mill. And from time to time, there will be data transfer from the registers of the mill to the variables in the store. Diba? What's wrong with this process? It's even true nowadays, no? Anyone? Can anyone explain to me what's wrong about this? What's the difference nowadays? Kung sa ano pa ito, programs are loaded individually, instruction per instruction from a hard disk. Shall we say we have slow? Yeah, it's slow. Why is it slow? Aguado? Oh, si Eman, no? You're saying it's slow. Why is it slow?
Because you cannot load multiple programs at once, sir.
Now, shall we say we use instead of using the Jacquard's loom, we use the hard disk para mas mabilis. Di ba? What's slowing the process is the Jacquard loom. Kasi ang bagal niya mag-scan, right? Bagal. So according to Alan Turing, it's 100 times. It can be 100 times slower than the Manchester baby. Diba? Shall we say we change the Jacquard's loom into hard disk? Will it hasten the process? Anyone? No. Why? Because there's a big difference between the speed of the hard disk and the computer register or computer store. Diba? Yung memory ngayon is very much faster than the hard disk. Do you follow? So it's always faster to run programs from memory than to run them from the hard disk, right? Do you agree? Everyone? So, instead of running them one by one from the input device, John von Neumann proposed that programs are wholly loaded. No? They're fully loaded by batch. No? Ibig sabihin, you do not run a program one by one, but you load it from storage or hard disk to memory in whole. Do you follow? So you need a large memory. Okay? Only then that instructions are data fetched one by one from main memory this time. It's not from the hard disk nor the Jacquard loom. Instructions are fetched sequentially from memory to CPU na, no? Not from the hard disk directly. Okay? This process is called fetch and execute cycle. Okay? So this is called the stored program concept. Do you follow? Everyone? Stored program concept because the program is fully loaded or stored first into memory before it's executed one by one. I hope you understand this, no? Okay. So, all computers nowadays are stored program concept. The stored program concept computers are then called Princeton class, no? Kasi sa Princeton nagawa. The non-stored program concept are called IBM class, no? IBM class kasi yung IBM galing sa Harvard from input, no, from punch cards. IBM is one of their punch cards. Harvard class, no? I'm sorry, Harvard pala. So Harvard class versus Princeton class. Who won? Of course, the Princeton class computers. Okay? Nowadays, all computers are Princeton class. And it's very much relevant for a long time. Now, you may ask, will this stored program concept ever be obsolete? Will this always be relevant? It's still not obsolete, right? Will there come a time that the stored program concept be obsolete. Anyone? Remember, no, that the hard disks are becoming faster and faster. Although memory devices are also becoming faster and faster. But the speed at which, no, the hard disks are gaining are much more mas malaki, no? Are much more aggressive than the speed of memory. Eventually, the maximum speed of memory will be reached. Do you follow? But the hard disks are still increasing very fast. Remember, you used to have an IDE hard disk, which is very slow, which is slow, and then you will have a SCSI hard disk, and now you have SSDs, right? And recently, Intel, no? Intel is designing a new SSD. I don't know what it's called, no? Nalimutan ko ang tawag. Dito, no? Sa Amazon ako napunta. It's not yet released, no? Hindi pa na-release, no? Okay? Okay? This Intel memory, anyway, I lost the real source, is considered to be 1/4 the speed of memory. Do you follow? Which means it's no longer magnitudes higher. Usually memory is 1,000 times faster than hard disk. But nowadays, with this Intel technology, no, RAM is orders of magnitude faster, no? So 6 Gbps ang RAM, ang ano is 750 Mbps. So magnitudes higher. But now there are SSDs that can reach 25% of the speed of RAM. Do you follow? Now, eventually, no, the RAM technology, which becomes cheaper, will move into the hard disk technology or storage technology. Okay. When storage will be fast as RAM, the stored program concept will be obsolete. You know why? Jesus is here. Anyone? Because there's no need to load the program again to memory because they're just as fast. Diba? Why load it from there when you're just wasting loading time? Okay, so we will go back to Harvard class, no? When hard disks will have the speed of RAM. Okay, so it's an exercise in computer architecture, no? They follow. So let's look at the structure of the IAS computer. No, this is important because this structure is still being followed nowadays. No, you have two main components: arithmetic logic unit and program control unit or control unit. No, the arithmetic logic unit does the multiplication, addition, okay, and so on and so forth. Okay, the program control unit does the fetch and execute, like the mill. Okay, so meron siyang program counter. Now, because we have CF and CV, diba? The program counter counts the instruction being executed. The IBR or the internal buffer register is divided, later split into two. This will store the instruction to be executed first and next, no? So usually the instruction part is split, no? This is split. The instruction part is moved into the IR, okay? And the address part, because an instruction will have an instruction code and operand address. The address part goes to the memory address register, okay? So in short, the program control unit does the fetch and execute that the IAS does, okay? And the arithmetic operations are done by the ALU, no? So we split 9 to 2 so that multi operations can execute at the same time with program execution, okay? Unlike Charles Babbage, no, the arithmetic logic unit and the control unit are merged into the middle. That's why he has a very complicated middle. Okay, any questions? Who just came in, tabudlong? Okay. So do you understand this? No? This is the arithmetic logic unit and this is the program control unit, which is split. Now the program execution, fetch and execute is done by the program control unit. This is like the mill without the mathematical operations, because the mathematical operations are done by the ALU. And it also has memory, the same concept as the store, but this time this is electronic memory. You have input-output equipment, which can either be in tape drives or in punch cards, okay? Does it have a monitor and keyboard? No. Okay, let's look at the actual IAS picture. Oh, so ito yung IAS, oh. It's how it looks. So it resembles the Manchester Baby or the no, but this time, no, instead of using gears, these are now transistors. Do you follow? I think this is the memory of coils. There's a picture of the IAS with John van Neumann. This is John van Neumann. I don't know who is with Robert Oppenheimer, no? Who's Robert Oppenheimer? Siguro teacher niya, ano? Okay, this is John van Neumann. This is the IAS machine. Okay? So walang ano, no, walang monitor, walang keyboard. Okay. Any questions so far? So now, the next important thing to discuss is the instruction set. Okay. So, how different is it? No? Halos pareho lang. It's almost the same as there are very close similarities as to the analytical engine. Can you explode this? You can download this, no? I downloaded this somewhere. Okay. Do you follow? We also have a load instruction, but this time, no, instructions are coded in binary. This is a code. This is the instruction. This is the equivalent unique binary code. Okay. Diba? This is borrowed from the analytical engine load. What's the difference? It now specifies the particular load value to be loaded to the accumulator register. No? Unlike the analytical engine where the first load goes to AX, the second load goes to AX2. Diba? Dito, when you say load MQ, the multiplier quotient register, where's that? It's loaded into the accumulator. So ito yan. When you say load MQ, whatever is in MQ is transferred to the accumulator. Okay? When you say load MQ MX, whatever is in memory, X is a memory, no? X is the address. Okay? Whatever is in memory address X is transferred to the MQ. Do you follow? Okay. Strange, no? Kasi most of the instructions are single operand. No? Unlike, actually, single operand lang ito eh. MX lang. Okay? Instructions are single operand. Okay, so programs are longer. Unlike in the analytical engine, instructions are binary, no? Which means they have two operands. Okay, store. Store is the same store, no? Store MX. Stores the accumulator. Okay? It's like the egress and ingress, no? So the address X in memory. Do you follow? Okay. Load MX. Transfers MX or loads MX to the accumulator. So whatever is the address in memory goes to the accumulator. Load minus MX converts MX to negative before loading it to the accumulator. Load absolute MX removes the value, no, or the sign of the accumulate of MX before loading it to the accumulator. Okay. Enforce, no, load minus MX, no, so on and so forth. Okay, there are conditional jumps. There are jumps, no, jump X 0 to 19 and jump X 20 to 39. Let us study this. Anyone? The first jump is also called jump to the left. The second jump is jump to the right. Do you follow? Do you follow? Okay. Why is that? Why is there a left and a right? Because 0 to 19 kasi is the left and 20 to 39 is the right. Why? Because there are 40-bit words. So, problema dito is it's not completely sequential, no? Program execution is not just vertical, it's also horizontal. Okay? So you have to be careful. And now we have a jump F. This is like the converse of CB. Kasi we will jump only if the accumulator is non-negative, 0 or positive. Diba? The CB will jump if the egress register is negative. Diba? So this is the opposite of CB, jump plus. Okay. Now there are two conditional jumps. This one is the jump to the left. This one is jump to the right. Okay. We will have an example of that later. So instead of operation cards, it has mathematical or arithmetic operations, no? Add MX, add absolute MX. You read this, no? Everything adds to the accumulator. Okay, adding is done such that the first argument is the accumulator, the second argument is a register, and the result goes back to the accumulator. Okay, there's also did, left shift, and right shift. Now, if you have a load, you also have a store. Since you have a 40-bit word, you will have a store to the left and store to the right. This is the same store that is used in the analytical engine. Okay. Any questions so far? Okay. Do we have time to discuss the actual examples? Any questions? No? Meron tayong samples, no? And then you will have a programming assignment, which I will introduce next meeting na lang para hindi magdubli-dubli, no? We are using a worksheet. Okay. This is the same factorial program. Hanggang factorial lang tayo ngayon, no? And then we will Fahrenheit to Celsius, meters to feet. And we'll also discuss the looping later, no? Because we will have here, no? Looping concepts. So we'll have a fourth factorial with loop. So this looks a little bit strange, no? It's a little difficult. I'll just introduce you the program, no? From the IAS. Why are we doing this? Because we are trying to show the evolution, no? From the analytical engine to the IAS. No? Para halos pareho lang, no? Okay, Excel 3 na ito. Okay. This is the same as the first assignment. Okay. So hidden mo na yan ngayon. Okay. Okay. Do you follow? Here's a program to compute the fourth factorial. Okay, this is now instead of variable, we now use M1, M2, M3, M4. And we only use the accumulator register. Do you follow? Yeah, pwede siya magkasya, magpalaki na lang. Okay? Diba? So ito yon. This is a fourth factorial program without loop. Okay? So we have a jump 5, 0, 9, 19. We jump to the left of 5. Okay? Do you follow? So every instruction, when it's an instruction, we'll have a left part and a right part. Ito kasi dapat dito ito, no? 5R. Ito yung 5R. Okay? But we are placing it, the actual physical location is here. But it's very difficult to trace. So therefore, we're just putting it below 5L. Now, after 5R is 6L. And then 6R, which is actually on the right of L. This is only for instructions. For data, we just numbered them 1, 2, 3, 4 because for data, the value will be 40 bits. For instructions, the value will be 20 bits. Do you follow? So strange, no? But this was later changed, no? Fortunately, nowadays, it's no longer that case. So the first is usually, now upon convention, no? We write the data first before the instruction. So the first instruction should be 0L ito dapat eh. Jump to the next, no? We discard 0R na lang, no? So jump to the first program. So nowadays, programs have data segments and code segments. Okay? So we store, wala nang N, no? This is the memory address because it's loaded, no? From hard disk to memory. So memory address 0 is blank. M1 is 4. M2 is 1. M3 is 1. No? And we will store the final product in M4. Okay. So the first command, let's trace this. Hanggang anong oras tayo? 9:10. Okay, malapit na lang, no? Just enough for that, no? Load M1. What's M1? Anyone? What's M1? 4. Store M4, which means we are going to store it here as the first partial product. Okay. Sub M2. So, ito yung ginagawa nyo. When you say load M1, AC receives M1. When you say store M4, M4 receives AC. This is the micro instruction. No? This is the program. This is the micro instruction. Okay. Receive, the arrow means receive. Okay. Sub M2. AC receives M of 2. So what is the accumulator here? AC receives M1. So nagiging 4 pala ito. No? Okay. What is M2? 1. So AC receives M of AC receives AC minus M2. So this becomes 3. You follow? Because they have 4 minus 1. This becomes 3. Okay. And then we have M1 receives AC. Store M1. Okay. M1 receives AC. So this is now 3. This is our next multiplier. Okay. Mul M4. So what it does is AC receives AC times M4. AC is 3 times 4. Okay. So AC becomes 12. Sorry, dito pala 12. Do you follow? And store M4. So nandito na ngayon. This is the partial product. Do you follow? And then sub M2, load M1. So AC receives M1. What's M1 now? 3. Okay. And then we have sub M2. So M2 is still 1. Ito. M2. So AC receives AC minus M2. So AC becomes 2. Okay. And store M1. So nandito naman siya. 2 na siya. Okay. And then we multiply again to compute. Load M4. This becomes 12. Okay. Mul M1. So this becomes 24. Do you follow? 12 times 2. Oh, M1. 24. And store M4. This is now 24. Okay. Okay. We store M4. Dito. 24 pala. Okay. Load M1. So M1 is now 2. So this becomes 2, the AC. Dapat inano natin lang. Let's freeze panes. Okay. Can you freeze your own panes now? Anyway, load load M1, so this becomes 2. And then sub M2. M2 is always 1. Okay. So this becomes 1. Okay. Store M1. So now this becomes 1. Okay. We load M4. This becomes 24. Mul M1. So this becomes 24 times 1. This becomes 24. Okay. And store M4. This becomes 24. Now this is like jump 4L. No? Jump to itself. Which means this is the halt. Okay. Any questions? Any questions? You can download that, no? I will not give you a new assignment yet because you have a pending assignment. Now, there's a Fahrenheit to Celsius. Okay. Same ano? So 132 we are going to store in ano in Celsius. So we jump 60 to 19 because 6L is the first command. What follows after 0 are data. So the initial value is 132. This is the constant multiplier, the divisor, and the aso na una M3 times 5 over 9 pala, no? Tama ba? Times 9 over 5. Times 5 over 9. Sorry, times 5 over 9. So we have load M1. AC receives M1. So AC is 32. Sub M2. M2 is 32. So AC receives AC minus 32. This means 100 minus 32 minus 32 is 100. Okay. Mole M3. So we multiply it by 500. And then div M4. We divide it by 9. It's 55.6. And we store M5. This is now 55, and we have whole. Any questions? Meters to feet. Ganon din, no? 4 to 19 because this is the first one. We have the constants 4, which is what we are going to convert. The multiplier is 0.328. And the result, we will store it here, no? So it's 3. We load M1. M1 becomes 4. Mole M2. So that's 4 times 3.28. This becomes 13.12. Store M3. So we have the result, and then we hold. Any questions? Okay, our next problem is looping. Okay? Ang next problem natin, looping. So, before we look at the fourth factorial with loop, we look at looping concepts in programming kasi there's no direct equivalent for CB. Baligtad nga yung CB ng ano no? Do you follow? The CB and the jump, okay, and the jump of the IAS are not the same. They are the converse. Baliktad yung effect. Jump plus kasi yung ano, right? Okay, jump plus in the IAS, but count backwards if negative. Jump minus yung sa ano, yung sa analytical engine, and we don't have a jump minus. Now you will see that it's difficult to do, no? Any questions so far? Now we don't have enough time to discuss the looping, so we will discuss it next meeting. Okay. Anyway, there's no assignment yet except the old one. So any questions? I will upload this. If you have no questions, we will dismiss the class. Okay. So let me just check the attendance kung sinong ano. So present tayo lahat ngayon. Arabaster, welcome back. Ano, si ano pala, wala. Giancarlo More. Only More is absent, no? Otherwise, you could have been complete attendance. That's good anyway. So, see you on Tuesday. Thursday, sorry, no? By the way, I'm planning to have a medical leave, no? And I'll give you assignments. I'm just going to be absent for a few days, no? 1 or 2, no? Anyway, I'll try to schedule it on time for the college fiesta. Para konti lang yung mawala na time, no? Any questions? So bye everyone. Thanks for coming everyone. I hope you're not.
Thank you, sir.
Thank you,
Bye,
sir.
sir.
Thank you, sir.
I'll upload the recording. I hope you find the recording, okay?